Hello, my name is Spencer Goldfine, and I'll be explaining the problem that our team set out to address. When we looked at the current landscape of games, we noticed that most of them tend to fall into one of two extremes. On one end, you have more complex games. These often have deep mechanics, multiple systems to learn, long tutorials, and a significant time investment. For experienced players, that depth can be rewarding, but it also creates a barrier to entry. If someone is new, or if they haven't played in a while, it can take a long time just to get comfortable enough to play the game. On the other hand, there are simpler, more casual games. These are very easy to pick up and play immediately, which makes them accessible, but they often lack progression, challenge, or long-term engagement. After a short period of time, players may feel like there isn't much to work towards. Because of this, players are often forced to choose between accessibility and depth, rather than getting both in the same experience. To make that more concrete, consider a player who only has 10 to 15 minutes to play. If they choose a more complex game, a large portion of that time might be spent navigating menus, remembering controls, or trying to reorient themselves in the game. On the other hand, if they choose a very simple game, they can start immediately, but the experience may feel repetitive and not particularly rewarding. Another example is a new player trying to get into gaming. A complex game can feel overwhelming due to the number of mechanics and systems, while a simpler game might not hold their attention long enough to stay engaged. The core problem we identified is the gap between accessibility and meaningful engagement. There are many options on both ends of the spectrum, but fewer experiences that balance quick, intuitive gameplay with a clear sense of progression and challenge. Currently, most games address one side of this problem well, but not both at the same time. That gap is what our project is designed to explore and improve on.
I wanted to go over the goals for our game. So goal 1 was to make the game more accessible. So for our project, we want to center around making a top-down experience that is more accessible, less frustrating, and more engaging for a wider range of players. One of our biggest goals was going to be the accessibility. A lot of games in this genre are known for being difficult and overwhelming, especially for new players. We wanted to keep that core idea of a challenge, but make it so players can actually understand what's going on and feel comfortable learning the game instead of immediately getting discouraged. Another important goal was to help players learn as they play. In many similar games, players often fail repeatedly without really understanding why. We wanted to design our games so that each run feels a little like a learning experience. Even if a player loses, they can still take something away from it and improve in the next run. We also focused on reducing frustration and confusion. A common issue in these types of games is players don't always understand what items do or how enemies work, or the decisions they should be making. That can make the game feel random or unfair. Our goal was to make gameplay feel more clear, intentional, so the players feel like their success depends on their decisions rather than just luck alone. Finally, we want to increase some replayability and keep players engaged over time. Since the game is designed around multiple runs, it was important that each run feels slightly different and rewarding, so players actually want to keep coming back instead of getting bored. In terms of use case, one example would be brand new players who've never played the game like this before. They can start the game and gradually learn the mechanics without feeling too overwhelmed, and instead of quitting early, they're able to understand the game and enjoy the experience from the beginning. Another use case is a player who's already played a couple runs and wants to improve. Instead of needing to look up guides or watch videos, they can learn directly through gameplay. Each run helps them build skill and make better decisions, which in turn makes progression feel more rewarding. We also considered casual players who just want to play for fun. Not everyone wants an extremely punishing experience, so our game allows players to enjoy the core gameplay without feeling stressed or stuck. This makes it more appealing to a broader audience. And then lastly, for our returning players. The game is designed to stay engaging over time. Since each run can feel different, players are encouraged to keep playing and experimenting with different strategies, which adds long-term value to the experience. Overall, our goal was to take the core idea of a top-down game and make it more understandable, less frustrating, more enjoyable, while it's still keeping the challenge and replayability that makes the genre fun.
My name is Stefan Johnson. I will be presenting the technology use section for our project. The core engine is Unity 2022 LTS with C# programming. Unity provided a 2D physics system, rendering pipelines, and animation framework that powered our game. We wrote over thousands of lines of C# code across multiple manager systems. For audio, we integrated Unity's audio source system with dynamic music switching between levels. Each level has distinct background music that changes as you progress throughout the game. We use Tech Mesh Pro for all UI elements, health bars, score, displays, tutorial text, and in-game statistics. This gave us crisp, scalable text that looks professional at any resolution. For version control and collaboration, we use Git and GitHub. This was crucial for our group as we were able to simultaneously work on different features without conflicts. Our testing framework is Unity Test Framework. We used this test framework and achieved over 70% test coverage with our code. We wrote both unit tests and play tests to ensure the game stability. One technology that worked exceptionally well was Unity's input system. It allowed us to support both keyboard and mouse aiming, giving the players their own choice as how they want to control the game. A challenge we faced was collision detection with fast-moving projectiles. We solved this by switching from discrete to continuous collision detection in the physics systems. And we added 2 box colliders, which prevented bullets from going through walls. We also implemented a custom room management system that handles enemy spawning, door locking, and level progression. This was built from scratch using Unity's component-based architecture. Thank you.
Hi, my name is Ricky Garrettson, and in this part of our capstone demo, I am going to walk through the full gameplay experience of Byte Breaker. In this game, the player's goal is to make it through all 3 floors, survive each room, defeat the final boss, and reach the victory screen. So as I play, I'm going to explain what I'm doing, what the player is seeing, and how each feature supports the overall experience. I'm starting here at the beginning of the game, on floor 1. Right away, the player can see some of the main interface elements. At the top of the screen, the UI shows the current floor and room progression, and at the bottom, there's a tutorial panel that teaches the controls during gameplay. The tutorial is one of the major features of the game because it helps the player learn naturally while playing instead of forcing them to stop and read separate instructions. Right now, I'm demonstrating the character using WASD. This shows the basic movement system, which is one of the core mechanics of the game. As I move, the player can immediately see the result on screen and start to understand how to navigate the room. Another core mechanic is using the arrow keys to shoot. I'm continuing through the first room while following the tutorial prompts. It is important because floor 1 is designed to introduce the player to the controls and the rhythm of the game. The player's goal here is simple: learn how to move, stay aware of the environment, and begin progressing through the rooms. Now I'm moving forward and showing the room progression system. At the top of the screen, the room progress indicator tells the player how far they've advanced in the current floor. This gives the player a clear short-term objective while still supporting the bigger goal of reaching the boss at the end of the game. As I continue through floor 1, the player is learning by doing. The game is using the tutorial, the room progression, and the UI together to guide the player without interrupting action. This helps create a smoother onboarding experience. Now I'm advancing to floor 2. This is where the game starts to build on what the player has already learned. The same core controls and progression systems are still being used, but the expectation is that the player is more comfortable now and ready for more of a challenge. As I move through floor 2, I'm continuing to use movement and room navigation to survive and progress. The result is that the player can feel the game escalating while staying oriented through the UI. This floor shows that the game is not just a single room experience, but a structured run that develops over time. At this point, I want to briefly show another major feature, which is the pause and setting system. I'm pressing Escape now to pause the game. Now that the pause menu is open, here the player can clearly see the settings screen, including options like mouse aiming and debug mode, along with buttons to resume or return to the main menu. We also made it clear how to resume the game, which improves usability during the play. I'm going to click Resume now. The result is that the game immediately returns to the same moment in gameplay, so that the player can continue the run. That pause menu demonstration is important because it shows that the player has control over the experience even in the middle of the gameplay. Next, I'm moving on to floor 3. This is the final floor before the boss, so the player's goal here becomes more urgent. At this stage, the player has already learned the controls, adjusted to the gameplay loop, and worked through the earlier floors. Now, they are pushing towards the final challenge. As I continue through floor 3, the major systems are all working together: room progression, movement, UI feedback, and player guidance. The player can see where they are, understand what they need to do next, and feel the tension building toward the end of the run. Now I've reached the boss encounter. This is the final challenge of the game and the payoff for making it through the earlier floors. The player has been using movement, awareness, and progression throughout the run, and the boss is where that all comes together. I'm starting the boss fight now. As I move and react during this section, the player can see that this is the most intense part of the experience. The result of everything that the player has done up to this point is the final test. Now that the boss has been defeated, the result of beating the boss shows that the player completes the run and reaches the end state of the game. Here's the victory screen. This is the final reward for the player and confirms that they've successfully progressed through all 3 floors and completed the game. This is an important feature because it gives closure to the full gameplay loop and makes the player's progress feel meaningful. It also adds an air of competitive stats, with stats being kept such as time, final score, and accuracy. So overall, this demo showed the player and their full journey through the game, starting on floor 1 with guided learning and progressing through all 3 floors, using the UI and pause system to stay in control, and then defeating the final boss and reaching the victory screen. That wraps up my section of the demo.